Hello everyone, and welcome to On-Site Question 2 solution for the large e-commerce company mock interview. So let's go ahead and review the problem statement and then check out the solution. Problem statement was this: given a list of integers, write a function that will return a list in which for each index, the element will be the product of all the integers except for the element at that index. So if you were given 1, 2, 3, 4, you return 24, 12, 8, 6, because you're multiplying by every other number that's not at that index. Okay, so we can't use division in the answer, meaning we can't just multiply 1 times 2 times 3 times 4 and then go about dividing by each element. So how do we go about doing this? Let's go ahead and think about our strategy first. So if you look at the list above with the multiplication, you'll notice we have repeating multiplications, such as 2 times 3 or 3 times 4 for multiple entries in that new list. So what we're going to do is take a greedy approach and keep track of these results for later reuse at other indices. We'll also need to think about what if a number is 0. In order to find the products of all the integers, except for the integer at that index, we're going to actually go through our list twice in a greedy fashion. On the first pass, we're going to get the products of all the integers before each index. Then on the second pass, we'll go backwards through the list and get the products of all the integers after each index. Then we just need to multiply all the products before and after, and then you have the final product answer. So let's go ahead and code this out so it's a little more clear. All right, so we have this function here with comments in case you want to check it out, but we're going to actually code this out ourselves. So first thing we're going to do is just start the function. We'll call it index underscore prod, and it's going to take a list LST. Let's go ahead and create an empty output list to start off with. So in order to do this, I'm going to say a list of none, and then multiply it by the length of the input list. And so now our output is a list of nones, just empty objects, but it has the same length as our output list, so we can go and switch out through indices on that output list. So I'm going to set an initial product and index for that greedy run forward. So I'm going to say product equals 1, and I'm going to set I equal to 0. And now here's what we're going to do. We're going to say, while I is less than the length of that list, we're going to say output of I, so output at that index, equals product. And then we're going to do a cumulative product. So I'm going to say then product equals LST I, that input list, that index. And then we just move forward. So that's our greedy run forward. So we set index as a cumulative product, multiply it by each index or element at that index, and then move forward through the list. So we're moving forward through the list until we've reached the length of that list. And then for a greedy run backwards, we're going to do the same thing. Reset product equal to 1. And now start index at the last. So instead of I equals 0, we're going to say I equal length of LST minus 1. So we're taking into account the fact that indexes start at 0. That's why we're subtracting 1 there. So our index is at the very last element of that list. And then we're going to say, well, I is greater than or equal to 0 since we're running backwards. What we're going to say is same operations as before, just backwards. So I'm going to say output of I is then equal to multiplying that product. Then product is equal to multiplying at that list. And then we're going to subtract from our I value. And then after these two greedy runs, we're just going to return the output. So let's go ahead and see if this works. Whoops. Index prod. Let's go ahead and get a list in. 1, 2, 3, 4, 5. And here we can see the results. So at the first index, we have 2 times 3 times 4 times 5. At the last index, we have 1 times 2 times 3 times 4. So in order to really understand what's going on here, it's important to review the solution. And one of the best ways to do that is to use print statements. So let's go ahead and run through this and add print statements so that we can see what's actually happening here. Remember, we're creating an empty list that's the same length as our input. So we have our output here. And then when we're running forward through it, we set our initial variable product equal to 1, and then set I equal to 0. And then we go through the list. So we have the I plus 1 statement here, and then I is less than length of the list. And then we say output of I is equal to the product. So your very first output is equal to 1. Then you take that product and multiply it by the index or the element at that index of the list and keep going. So you're just going forward through the list and multiplying everything. Then, in that second loop, you're actually going backwards. You're taking that product set equal to 1, setting the index, and then subtracting from that high index as you move backwards. All right. So as far as adding print statements, it might be useful to perhaps add a print statement here. So we can go ahead and print output. Let's go ahead and print something, and I'm using Python 2 printing style. So I can say first forward pass, and then print the output. Whoops, there needs to be a comma there. All right, now let's go ahead and check what that looks like then. And so you notice in our first forward pass, what do we have here? We have 1, our initial, 1 again, since we started with a 1, and then 2, which is going to be 2 times 1, 6, which is 2 times 3, and then 24, which is 1 times 2 times 3 times 4 here. All right, so note what's happening here. On our first forward pass, we're getting everything before. And on our second pass, when we go backwards, we're getting everything multiplied in reverse. All right. So I encourage you to look through the solution and add tons of print statements so you really understand how your forward pass and backward passes are working. The key to understanding this is the print statements and understanding how that greedy run forwards and backwards will get you your final result that you want. Okay. Luckily here, we're just using ON time and ON space complexity. ON space complexity because we initially create a list that's n. So if your list input is n elements long, then your output you created is n elements. So you're using ON space. And ON time because you're going one pass here in n, and another pass in n, which is going to be order 2n, but since 2 is a constant, you can drop it and just get order n time. All right. Again, make sure you review the solution, use print statements. Those are really helpful for understanding the solution. But remember, it's just a greedy pass forward. So on the first pass, you get the products of all the integers before each index. And then on the second pass, you're going to go backwards to get all the products of all the integers after each index. Then at the end, you just multiply all the products before and after to get the final product answer, which is what we're doing on this step. All right. That being said, hopefully you did well on this. Good luck, and make sure you review the solution, and I'll see you at the next lecture.